Hello, my dear children. This is P. Venkateshwarlu, PGT Physics. In previous video, we have already discussed about energy of orbiting satellite. In this video, we have to discuss about satellites, types of satellites, what are the means, geostationary or polar, geostationary or geosynchronous or polar satellites or sun synchronous satellites, and at last we have to discuss about weightless and weightless in satellites. So this is the last content, my dear children. So coming to satellite. What is the satellite, my dear children? Yes. What is satellite? What is satellite? Satellite is a body which is revolved around a heavier bodies like planets with a particular orbit is called satellite. What is satellite, my children? Satellite is a body which is revolved around a comparative large bodies. Okay, understand? See here, now we have satellites are two types. So what are they? Natural satellites. Natural. And second one, artificial. Okay. So how many types satellites? Yes, two types. What are they? Natural satellites and artificial satellites. Okay. So what is natural satellites? Yes. So naturally occurring bodies which are revolved around heavier bodies like sun and earth. Okay. So example for natural satellite is moon is a satellite. Moon is a natural satellite of earth which is revolved around the earth in a particular time in a particular orbit. So what is orbit? Orbit is a path around a heavier bodies, okay, with a fixed radius, okay, so in which satellite can traveling. Okay, understand? So yes, what is the example of natural satellites? Moon. Moon is the natural satellite which is revolved around the earth in a particular orbit in a particular time. So coming to artificial satellite. So artificial satellites are man-made satellites which are revolve around heavy bodies like moon, earth. Okay, so because of the satellites, the purpose of satellite is to find the shape of big bodies like earth, moon, and mineral exploration, meteorology, and communication purpose. Because of this purpose, human can made satellites. So this artificial satellites are two types. Okay, artificial satellites are two types. So what are they? Means geostationary, geostationary satellites. Geo means earth. Okay, geostationary. Stationary means rest. Okay. The satellites are revolved around a earth with equatorial plane. So means with respect to earth and satellite, both are observing rest. Okay. So earth rotates itself and it moves around the sun like that. So the satellite also revolving around the earth with the same time period. Means every 24 hours the time period of earth is equal to the time period of this satellite. Okay, next polar satellites. Polar or sun synchronous satellites. Polar or sun synchronous satellites. Polar satellite means the satellite which are passing from north to south. Only the path of satellite is always from north to south, like this. Okay, so around the Earth surface, the polar satellites are above the 500 to 800 kilometers. It will vertically revolve around vertical circular motion. Okay, understand? So coming to how to discuss about one by one clearly. Coming to first one, geostationary satellites. Geostationary satellite. Geostationary satellite. Okay, geostationary satellites are geosynchronous satellites. Geostationary are geosynchronous satellites. Here, so we know that Earth having spherical shape. Okay, so we know that Earth rotates about its own axis. Okay, understand? Always Earth rotates west to east. So here in this case, consider one satellite. Consider one satellite. So which is revolve around the Earth. Okay. So while the Earth is rotating, the satellite also revolve around the Earth. So with respect to one to another, by observing from the Earth or from the satellite, both are become stationary. Both are becomes stationary. Understand? So with respect to Earth, the planet, the satellite which are rest, which are stationary. Okay, means the time period of Earth is equal to the time period of the satellite. Okay, understand? So which is always focusing at one particular point. Suppose here. Okay, so every rotation it will, the area covering by the satellite is same. Okay, understand? See here the time period is 24 hours. 24 hours. So because the rotation of Earth about its own axis is 24 hours. At the same time, in this case, satellite also, the time period of the satellite is 24 hours. So that's why, so here consider one point. Due to this point, these two are by observing which are in stationary. Which are in stationary. Okay, so the applications of this geostationary satellites are communication. Okay, signal transmission and communication. So observing the particular area for meteorology and mineral exploration. Okay, so some of the more applications is there. Okay, so now coming to next one, sun synchronous or polar satellites. Okay, understand? Sun synchronous or polar satellites. Polar satellites. Okay, see here in this polar satellites, the satellite which are revolved around the Earth based on the poles. Okay, so we know that the poles, north, south pole. So the satellite which revolved around the Earth surface above 500 to 800 kilometers. So the satellite which is revolved in a particular orbit. Okay, understand my children? See here, this is the Earth surface. We know that north and south, east, west. Okay, so here in this case, so the satellite which is revolved around the Earth based on the north and south like this. Okay, see from south to north and outside of the Earth north to south like that. Okay, so like this from here to, from north to south like that, north to south, south to north. Okay, understand like this, the satellite which revolves like this. Okay, So in this case, at the same time, Earth will rotates about in own axis, and the satellite will always passing from based on the poles like this. Okay, so by seeing the sun synchronous satellite, which covers the total area of the Earth, Okay, understand the time period of the artificial satellite is 100 minutes. 100 minutes. Okay, so every 100 minutes the satellite which is revolve around the Earth based on the poles. Okay, north, south poles is there. Based on the poles, the satellite which is revolved in a particular orbit. Okay, the time period of the satellite T is equal to 100 minutes. T is equal to 100 minutes. The applications of this sun synchronous or this polar satellite is spy purpose, means spy means in military purpose. If bunkers or enemies are they are to find the enemies, so army purpose or spy purpose, and to find the perfect shape of this earth and meteorology. Okay, and different purpose also here. Polar satellites are used by scientists or astronauts. Okay, my children. So this is about polar satellites or sun synchronous satellites, means which are rotating or which are passing from always north to south, south to north. So while in this case Earth also rotating about its own axis. So by observing this satellite covers the entire area of Earth. Okay. So after this we have to discuss about weightlessness. Weightlessness, my children. Okay, weightlessness means no weight. It means no weight. See here. So many situations we can feel. So our weight becomes less. Say, my children, that situations. Yes, first one, lift. So while lift going to down from stair. Okay, so you can feel somewhat less weight. Understand? So then giant wheel. Okay, giant wheel also you can feel some weightless. Okay, here, so what happened? So when the acceleration of the body, freely falling body is equal to G, A is equal to G means acceleration is 9.8 meter per second square. So a body or a person feels weightless. Understand? So consider a lift. In lift, a person can move down, or in an elevator, the person moves down. So in this case, if the acceleration less, so the person can feel also less weight. If the acceleration is equal to 9.8, the person weight is 0. Okay, so before that, what is weight? So weight is a force due to gravitational acceleration due to gravity. So due to acceleration due to gravity, Fg is equal to mg. So because of the acceleration due to gravity, a body gets weight. So on the surface of the earth, weight of the body is equal to numerically, which is equal to acceleration due to gravity, means 9.8 newtons. Okay, so the units of weight is kilogram weight, gram weight to gram weight kilogram. 1 kilogram weight is equal to 9.8 newtons. 1 gram weight is equal to 980 dynes. 980 dynes. These are the units. These are the units. Okay, simply here the acceleration due to gravity. The acceleration due to gravity which is equal to acceleration of the body, we can say weightlessness. Weightlessness. Okay, understand my children? So how you can observe that weightlessness? Okay, understand? Yes, I say one example. This is the elevator. This is elevator. Here one person is standing. Okay, here one person is standing. So how by observing how the person get so weightless means by taking a weight mission. By taking weight mission. See here, weight mission is there. Weight mission. This is the reading is say it is 60 kg. Say it is 60 kg. Okay, so when acceleration of the lift moves downward, which is equal to g, means A is equal to g, that is equal to 9.8. So means it is impossible to get acceleration due to gravity because of acceleration. So while a person moves down to earth, moves down in elevator, it is impossible. Okay, so damage, it causes the damage. Okay, so you can try if possible, if you can cut this thread. Okay, whenever freely falling body, it reaches the acceleration is equal to acceleration due to gravity. So in this case, we can say freely falling body. Okay, like that you can cut this big thread, so you can feel acceleration is equal to acceleration due to gravity. At the time, so the weight mission shows 0. Okay, so while moves downwards, acceleration equal to acceleration due to gravity, the person weight becomes 0. The person weight becomes 0. Understand, my children? So this we can say weightlessness. So for a freely falling body, or for a freely falling giant wheel, or for a freely falling elevator, okay, if which acceleration reaches to acceleration due to gravity means 9.8 meter per second square, a person can feel weightlessness. Okay, so mass is there, but acceleration due to gravity becomes 0. Okay, both are equal means the resultant acceleration is 0. Due to this, a person or a body can feel weightlessness. Okay, so next after this weightlessness in satellites. Weightlessness in satellites. Next we are going to discuss about weightlessness in satellites. Satellites. Okay, so many situations. So in movies or in TVs, we can observe that in satellites, astronauts are floating. Means they are not walking, they are flying. Okay, so can you observe that? Yes. Okay, in this case, so we can assume that acceleration due to gravity is 0, means no gravity. No gravity, we can say the word is no gravity, and null point. Null point means where the acceleration due to gravity is 0, that we can say null point. Okay, at null points we can feel 0 gravity, means man and things are flying. Okay, are floating, we can say that is floating or flying. Okay, so in this case what happened, how the acceleration due to gravity of an orbiting satellite. Okay, see here, this is Earth. Okay, you can consider Earth and here satellite. This is satellite. Okay, see here, we know that while satellites revolve around the particular planet like Earth, so which here in this case the centripetal force is equal to acceleration due to gravity of the force of the gravity. Means centripetal force is equal to gravitational force. Okay, understand? If both are equal means, here net force acting on the body is 0. Okay, there is no force means what happened? No gravity. Okay, so in this case we can't get normal reaction. Here there is no normal force. Say here 1 by 2 mv square minus mg is equal to ma. Okay, understand? In this case, so both are equal. If here we can get g value 0. Okay, understand? Acceleration due to gravity 0. Understand? Means otherwise we can here n means n is equal to mc. Okay, here there is no normal force. Means mc is equal to 0. Okay, mc is equal to 0 means acceleration due to gravity is 0. Understand, my children? So we can say so the centripetal force is equal to gravitational force. So instead of this, Fg minus normal force is equal to ma. A means acceleration of the satellite which is revolve around the Earth. So Fg, we know that capital G, capital M, small m by r square minus n, that is equal to ma. Okay, understand? Here, so there is no normal reaction. So when normal reaction, we can consider a body is placed on another body, okay, with a physical contact. Here there is no physical contact between Earth and satellite. Okay, understand? So in this case, the acceleration here, the gravitational force is equal to the product of mass and the acceleration of the satellite. Okay, due to this, the satellites revolve around the particular planets. So in this case also, there is no normal force. Means n is equal to mg. So n is equal to 0 means g is equal to 0. Understand, my children? So this is about weightlessness in satellites.